Hello, everyone. Thank you for attending this panel. I'm Emilie Bodoin, the founder and CEO of Pure Lithium. We're a vertically integrated lithium metal battery company. What on earth does that mean? We own and control the two main components of our battery. The anode side is lithium metal, and the cathode side is vanadium oxide, all that can be sourced in the US and through localized global supply chains. So our company was founded in 2021 with Professor Donald Sadoway from MIT. Don sits at the intersection of batteries and metallurgy with a lot of companies. Boston Metal makes carbon-free steel, grid-scale batteries, and a company called SES that many of you have heard of was spun out of his lab at MIT. We have a small board of directors. We're backed by Oxy Low Carbon Ventures just invested in us. And they have board seats. We're backed by the PIF and a whole bunch of investors. So I'm going to start just talking about lithium-ion batteries and move into lithium metal and then explain our battery and how it really disrupts the entire supply chain, which was the point of it. So our beautiful lithium-ion battery was invented for that Sony Walkman, and that changed my life because I could just listen to my U2 tapes on the way to school. It's amazing. The C rate, right, the power that thing needs is very, very, very little. We took the same beautiful chemistry that Stan Whittingham and Goodenough and Nishino invented and applied it to a cell phone and applied it to a car. And before we did any of that, we didn't really stop and think about national security and the environment. So it's an interesting predicament that we find ourselves in now. And we have a partnership with Stan Whittingham, who invented this lithium-ion battery. And when you talk to him now, you ask him, what were you guys thinking? They weren't thinking. Nobody was thinking about supply chain when this battery was invented. It's a 40-year-old technology. So it's not going to save the planet today. We need to invent our way out of this problem. Lithium metal has the highest energy density of any chemistry that we know of. It's just inherent. We've had two battery chemistries in our entire lifetime that have been scaled to gigawatt scale, and that is lead acid and lithium ion. We're going to have another one, just like the vacuum tube displaced the transistor. So lithium metal was invented in 1977 at ExxonMobil, an oil company, by Nobel laureate Stanley Whittingham. And basically, look at the battery on the right. That's our little 3-amp hour battery. Look at the cell phone battery on the left here. It's almost half of the size. So just a good visual. Lithium metal is half of the size, half of the weight, and it can get cheap if the lithium is cheap. One of the reasons that it hasn't been enabled yet is because of the cost of lithium metal. There really isn't a demand for these next generation batteries yet. So lithium metal is very expensive. And I've been in this space now since 2012, and this company was really born out of frustration. How do you make this beautiful lithium metal battery happen? First, you have to solve the supply problem and the cost problem. So we set out to do that. Right now, there are a few methods to make lithium metal, and Marina has one and is going to tell you all about it. Ingot extrusion is the traditional path, physical vapor deposition, and what we do is we use electrodeposition. It's using electrons to do work. We have a membrane that we use, and we take a little bath of lithium salts, aqueous lithium brine. We put it through our electrodeposition process, and we make an anode in one step. A lithium metal electrode, really, or anode in one step. It's very smooth, very even, plus or minus half a micron of tolerance, and we put it in our own battery. We can do this at a cost of $15 a kilowatt hour, and if we have somebody's very cheap brine, $6.70. So now this becomes realistic, right? Because today's lithium-ion battery, the DOE wants it below $121. If you've got this expensive lithium in it, you won't meet that target, and nobody wants to buy something that costs a ton of money, right? The battery has to be cheaper or the price of lithium ion and perform better. So that's where we started. The other issue that we really needed to tackle was the supply problem. So lithium, as you know, it mostly comes from the Atacama, it comes from Australia, it comes from all over, but it takes a long time to get in your battery, okay? It's gotta go and it's gotta be reprocessed, made into a cathode active material, then made into an electrode. With lithium metal, if you make it from an aqueous brine source like we do, you can get it from anywhere in the Smackover, in the US, all sorts of places. Our partners, E3 in Canada, it's just readily available. There's lithium brine all over, right? So we take it out of the ground and make it right into an electrode. We can do it in a day. You don't have to, it's much more simple in a lot of ways than carbonate or hydroxide. So now we have this lithium metal component. It's easier to make in a lot of ways and faster to bring online. So now our battery is getting a little bit more exciting to think about. Today's lithium ion battery, on the right, you see it's got a graphite scaffolding, and you need 1 lithium for 6 carbons. So you get this big clunky hulking thing. Our battery on the right there, you see that lithium metal anode, it's all by itself. And then we use a cathode that doesn't contain lithium, that's made of, please don't be shocked, vanadium oxide. It does exist. I will prove this to you. And our battery has no nickel, no cobalt, or graphite. I'm going to just say it again. No nickel, no cobalt, no graphite. And it's not magic. It's called vanadium. That's been around for a long, long time. So vanadium is actually more abundant than nickel. It is the 5th most abundant transition metal in the Earth's crust. It's mainly not used as a battery material. It's used in vanadium redox flow batteries, but that's not what we're talking about. We're talking about an intercalation cathode invented by Nobel Prize winner Stan Whittingham. Vanadium and lithium are co-located. The United States of America happens to be the largest producer of secondary vanadium, US vanadium. And there's lithium all over the US. This is the case in Canada, South America, Saudi Arabia, Australia. You can have local supply chains and control the 2 most active components of your battery, the anode and the cathode, if you want to adopt lithium metal. And I've got a surprise for you. The battery works really well. So it has twice the capacity of LFP and even a better safety profile. This is real. We can fit 2 lithiums into our vanadium cathode, which is a very, very big difference if you think about the flop of the lithium ion battery. So Stan Whittingham spent a lot of time. He did a very nice study for us. If you have your typical NMC, NCA cathodes, right, and they start to get hot, they exhibit exothermic behavior and oxygen evolution. Vanadium oxide does not. So there's not going to be added oxygen to put in your fire. So now we're even getting to a point where, geez, this thing's intrinsically safer. And now look, we don't have volumetric expansion because when you put lithium into vanadium, it doesn't expand all over. We're now, by accident, solving a lot of problems that people have because they're using traditionally available materials that were invented for lithium ion to go into a lithium metal battery, and that doesn't make any sense. It's available, but it doesn't make any sense. So we need to tear the entire situation down, and I'm going to quote President Biden, we need to build back better. We need to build a new battery, and we can absolutely do it. We can't put them in everybody's cars today, but if we work together, we can do this. We have a lot of patents. We have very heavily protected IP around our lithium extraction technology, which is just to make electrodes for our batteries and our battery performance. We're in Boston. We're a team of about 50 people. And right now we're making cell phone size batteries and working toward a pilot line. So I hope that I've left the audience with some interesting thoughts. And I just want everyone to understand lithium metal and vanadium oxide, it's not magic. It's not some crazy new fancy chemistry at all. It's been around for a very, very long time. But when we're having problems like graphite, we can't get it, export bans. Nickel, dirty nickel comes from Indonesia. That's not going to change. We have all these problems. So let's build our own supply chain and let's aggregate some things that make a lot of sense. So with that, I say thank you and look forward to questions.